ChemCat, your friendly chemistry tutor.
The Bronsted-Lowry theory on acids and bases. You may know that acids burn and bases clean, but they actually have more to their personalities than just that. Some go by the name of Bronsted-Lowry, and others prefer being called Lewis. Yeah, let's get into it. The Bronsted-Lowry, or Lewis theory, on acids and bases is basically just cat drama. One can't stop giving, while the other won't stop taking. It all just depends on who starts the chaos. Today we will focus on the Bronsted-Lowry theory. This theory is all about protons, aka hydrogens, being thrown around. A Bronsted-Lowry acid is a proton donor. It gives away a proton and becomes less positive. A Bronsted-Lowry base is a proton acceptor. It takes a proton and becomes more positive. Imagine two cats getting the zoomies late at night and playing with a ball of yarn. The cat that is holding the ball is the acid, while the cat that is empty-handed is the base, and the ball represents the proton. The acid cat throws the ball, and the base cat catches the ball. That's only one side of the equation. What do you think happens after this exchange? Well, the acid cat is now empty-handed, while the base cat now has the ball on the product side of the equation. Here, the acid cat that once had the ball is now called the conjugate base on this side because it's empty-handed, while the base cat that once did not have the ball is now called the conjugate acid because it's full-handed. If you get confused by the conjugate situation, just look at each side of the equation. On the reactant side, the acid cat has the ball, while the base cat does not. And on the product side, the conjugate acid cat has the ball, while the conjugate base cat does not. The OG acid or base transform into their conjugate forms after they donate or accept a proton, respectively. So just remember that the OG cat throws the ball and becomes the conjugate base, while the OG base catches the ball and becomes the conjugate acid. Acid cats seem to always have the ball, whether they're OG or conjugate. Base cats seem to always be empty-handed, whether they're OG or conjugate. Let's take hydrogen chloride, or HCl, and ammonia, or NH3, for example. On the reactant side, HCl is the acid that donates its hydrogen, while NH3 is the base that accepts the hydrogen. Now, as a result of this, HCl becomes Cl- on the product side, while NH3 becomes NH4+. Cl- is the conjugate base, while NH4 is now the conjugate acid. Here is a second example. We have hydrogen fluoride, or HF, and cyanide, or Cn-. On the reactant side, HF is the acid that donates its hydrogen, while Cn- is the base that accepts that hydrogen. Now, as a result of this, HF becomes just F- on the product side, while Cn- becomes HCN on the product side. F is the conjugate base, while HCN is the conjugate acid. Now it's your turn. Identify the Bronsted-Lowry acid, the Bronsted-Lowry base, conjugate acid, and conjugate base in the reaction below. Please pause the video and return when you are ready. Welcome back! Remember that the acid donates its proton, and if we look here, H2S looks like it definitely has one less hydrogen on the product side. So H2S is definitely the acid. When it comes to OH-, it looks like it actually gained a hydrogen on the product side. So this is definitely the base. The molecule that now has the hydrogen on the product side is H2O, so this is the conjugate acid. And the molecule that does not have the hydrogen on the product side is HS-, so that is the conjugate base. Here is a chart that highlights the key differences between the Bronsted-Lowry theory and the Lewis theory on acids and bases. Feel free to take a screenshot. Thanks for watching. Stay tuned for the next video, which will be about the Lewis theory on acids and bases, and it will also have a free full-size worksheet for the Bronsted-Lowry theory versus the Lewis theory. If you have any questions, feel free to email me at chemcat786@gmail.com. And as always, please like and subscribe to support this channel.